So with that, here's the presentation. So what I'm going to talk about a little bit today is a project we've recently done with a customer where we were kind of splitting out and using the C++ control along with a CODESYS application in order to control a process system. So first things first, a little bit about maskine. So I'm the president of maskine. We're I'm a mechanical engineer by education. Got a bachelor's in mechanical engineering from Rose-Hulman Institute of Technology. I've been working with CODESYS-based applications for 10 plus years now, and now what I'm doing currently as president of maskine, we're a systems integrator that focuses specifically on programming CODESYS applications. So unlike a lot of systems integrators, that's our bread and butter is programming them and also using CODESYS, not just a variety of other PLC platforms. Because of that, we kind of work in a very wide variety of different industries as far as the applications that we work on, but typically there's some sort of CODESYS application behind it. We've been around since 2017. There's currently 10 of us, 8 of us are controls engineers that work on applications with customers. And we serve the US, anywhere in the US, predominantly the West Coast, but also a lot of customers on the rest of the country from our offices in Tempe here in Arizona. As Chris mentioned, we're also a CODESYS systems partner. Along with this, and what's relevant also to this application, we're also a member of the Beckhoff Integrator Group, one of the very well-known CODESYS platforms out there that we use for a lot of the applications that we work on. Kind of the philosophy that maskine uses when we program our systems is that we kind of believe that a lot of industrial automation utilizes kind of outdated technologies and things that are very common in the typical programming industry. So what we do is we utilize modern programming concepts in industrial automation to kind of maximize reusability and efficiency. Things that we use to do this are object-oriented programming. This reduces the time that it takes for us to reprogram a system because we can use the same kind of code over and over again. It also makes it a lot more efficient to execute because, again, it's the same sort of to both write and execute because it's all using kind of a lot of the same things over and over again. And we don't have to write everything from scratch each time. It also provides a lot of flexibility for the final application because it's easier to kind of modify and change things and stuff like that. Another tool we use is source control. It allows us to have version management. We have control of who's changing things. We can see who changed things. We utilize a lot of libraries. So one of the tools we use is we have an internal library that we've developed and we maintain. So we've developed it and tested it. And more importantly, it's been tested. So when we come into an application for somebody, we have this code and kind of building blocks like the Legos, so to speak, that we can kind of snap together to create the application rather than having to write all of the code from scratch. This also results in both reduced programming time because we don't have to spend as much time writing the code, but at the same time, it also reduces what can often be more critical, the deployment time, because as we go to the customer, we're on site and we're working on starting up a machine, we don't have to test every little piece of this. We have already working manual control and things like that that just speed up that process. And then finally, one of the biggest tools we really prefer to use is PC-based control. Something that obviously is the heart of how CODESYS works, but this really helps provide applications for customers that are much more powerful. We get really quick scan times. We get really, can put a lot of load on a processor and not have to worry about things like that. It also makes it a little bit easier to integrate with IT because we're kind of utilizing tools that everybody's already comfortable with. And then finally, the cost to performance ratio is very similar, or is second to none. So these tools are kind of what this philosophy, underlying philosophy of how maskine likes to approach automation is why we're so well aligned with CODESYS and think that CODESYS is the clear choice for utilizing new advanced applications in automation these days. So in this, because of that background and that our approach to automation, this particular client came to us because to help them with this application that they're working on. So this is a customer that was accustomed to traditional software development. So they went and looked in the industry and they saw, okay, we can look at some of the more popular PLCs or the most popular PLCs in the United States right now. And they didn't understand why these were the kind of tools that they were being used. They were accustomed to all the text-based code, but object-oriented code, things like that, and ladder just wasn't going to be an option for them. They wanted to continue to use their traditional software development processes, languages, and tools that they're used to. So even switching entirely to a structured text-based application, even though it allows a lot more flexibility through object-oriented programming and those sorts of tools, still wasn't going to be the perfect application for them because it still represented a big shift in their mentality from how they typically did things. The other things is they were really looking for tight integration with a lot of higher level systems. So traditionally, this is all done where oftentimes with PLC applications, this is done where each individual application talks to the higher level system individually, but this can also create a lot of challenges with integration. So they were looking to have kind of a single point of access and have a really easy integration with third-party ancillary systems without having to build a lot of internal tools. They're also accustomed to using rapid deployment using continuous testing and integration pipelines. So they wanted to be able to iterate quickly and utilize tools that kind of already natively were picked in rather than having to build particularly custom things that they needed to use for this particular application. And lastly, and certainly one of the most important, they needed to make sure that we were providing safe control of the system, not only to safeguard the machine, but also the people working on it. So that kind of is two separate pieces, right? We have interlocks that protect the machine from destroying itself, but that may not hurt a person. And we also have the other aspect, the most important part, when you hit that e-stop, does the machine actually stop? And is it something that we can rely on? So what we kind of did is we came up with a couple different ways that we could do this. So one way is we could do it the traditional way and only use a CODESYS PLC. So the customer came in knowing that we wanted to use CODESYS for this because the other applications just weren't gonna, it was not gonna have the power or the kind of approach to programming that they were looking for. So the two different options we evaluated was doing only a CODESYS PLC and then integrating that with a lot of higher level systems. This does, of course, have some advantages as far as having a single deployment of a single application is a little bit easier to maintain. The real benefit that we all know and love of CODESYS is having real-time control. This is something that's super important depending on the application that you're working on. If you have anything with motion, PID, that kind of stuff, it is important. And then having a robust safety system. And we know that CODESYS PLCs do have a robust post-safety PLC. However, one problem with CODESYS for this particular client was it does require structured right code for it. Another thing is that if we're gonna integrate with a bunch of ancillary system services, it takes a little bit more to integrate it because each one of them needs to be connected and tools need to be utilized to do that. So the other option we explored was utilizing a hybrid system to do this. So what this looks like, we'll go into a little bit more detail shortly, but utilizing a higher level language to write the sequence level logic, but then using CODESYS to control all of the hardware and also the safety side of it. there's some benefits to this, which is that we can use any programming language that has an interface with OPC. Anything that can run on a server and talk to the PLC is something that we can use. This also means that because we can pull from a language that lives more in the IT world, we can utilize pre-built integrations to ancillary systems. So there's no need to find ways to connect these different tools because it's something that's already available and often free and open source. Another benefit is that it has native integration into the continuous development pipelines and tools that, again, all these tools from the IT world that are typically used for a lot of different of these applications. Finally, because we're still using a hybrid system, it doesn't make any difference for the robust safety system because we're still utilizing CODESYS on that side. Some downsides of this, though, it does mean a more complex setup because we now have to maintain both the C++ side and the CODESYS side. And anything that we move into the higher level language, the C++ side or whatever other language we're going to use, we lose the real-time control to some degree because we are now waiting for the information to come back from CODESYS and that sort of thing. In this particular application, though, there's not a lot of motion. There's no motion control and not a lot of things that are, the whole system is relatively slow. So it wasn't a huge drawback for this customer. Another thing is that some of those benefits of the hybrid system, particularly using all of these and really were huge benefits to them and things that they placed a lot of weight on. So what we ended up doing was going with the hybrid system. So we're going to have both a CODESYS PLC and a higher level control running it. The way we broke this down is really into 3 different pieces. So the higher level control is the C++. In this case, we're using C++. However, you could really utilize whatever language you want. Inside of here, we're going to do a few of the different things. So we're going to have the sequence logic. So in this case, if we're running opening valves, things like that, the actual sequencer that's going to run through the process is going to be running in the C++ side. From here, it's going to send and receive data to the PLC devices on the CODESYS side. So that way, anything that is related to the sequence, it still has interaction with the physical system, but it's going to be through the CODESYS PLC. This is also, we're going to manage alarms. And then, as I'll show in the next slide, also how this same area is where we're going to interface with both our user interface, our time series graphing, databases, everything like this. So from an actual control side, all that's happening, though, in the C++ side is running the sequence, sending and then interfacing with the CODESYS PLC and any alarming and that sort of thing. In the PLC, we're now going to we created what we call device interfaces. So what these are going to be is function blocks that really came from some modifications of our existing library, where they're going to control each physical device on the system. So we built kind of an interface that the C++ side can interact with. What these interfaces do is they do scaling for any analog devices. We do communication with anything that's not a standard digital or analog I/O point. So there's going to be serial communication, Modbus communication, any I/O link, that sort of thing is going to happen in here. And then we're going to link it to the physical hardware. And then this provides a standardized interface for all of the different devices that the C++ side can interact with. So it can read the values that we're seeing, and then it can write new commands back to it. Another thing that the PLC is going to do is, as I mentioned, we're not going to have real-time control in the C++ side on this. So we didn't have motion in this particular application, so that wasn't a huge issue. But we did make sure to put any type of control loops, our PIDs, things like that, in the CODESYS PLC so that we had the real-time functionality of those. And then finally, and one of the most important pieces is that it's going to go in the CODESYS PLC is the interlocks. We wanted to design the system in a way that if we were to lose connection between the CODESYS PLC and the C++ side, that the system could still be safely shut down without damaging the system or damaging the device. So any type of shutdown sequences or interlocks are going to live in the CODESYS PLC, so that if And we haven't had issues with this, but if something were to happen with the C++ side, it doesn't cause significant issues. And then finally, this last piece is what we're very used to seeing the separation of, is the safety PLC. So anything that's e-stops, anything that prevents humans from getting hurt, really, is going to live in the safety PLC and be completely separated from these other layers. So from a hardware standpoint, this is what this ended up looking like. So on the left, you can see we have our we have the C++ application. So the way this really looks is we have in the physical system is that they have an on-premise server that's running a Kubernetes cluster that has different Docker containers that are running the different pieces of this. So we have the C++ application, which is running the sequence for the whole system that we just discussed. We're utilizing OPC UA to communicate between the C++ application and our CODESYS application running on a Beckhoff CX6030. In addition, we have other different tools that are involved on the server, such as there's a database on there. We're using Grafana to help capture data. There's a front end that's developed to show the user instead of in place of an HMI. So what this is doing, and one of the big benefits that the customer got out of this, is now all of this stuff in the server can utilize any pre-built open source or not open source, but any pre-built kind of tools from the IT world to communicate and set up these systems. So it removes any need for custom applications between them. Then in the main safety PLC, or the main panel, we have an IPC that's local to the system, so that if something were to happen to the server, we still have local control, if only to shut down. So we have this IPC that's running CODESYS, and then we have a twin-safe safety processor, which is running the safety logic, and finally a bunch of remote I/O panels, which is all connected over EtherCAT. So let's dig into a little bit further into this piece of it, right? So the connection of the OPC UA server to the Beckhoff IPC along with the C++ application. So the way this works is that on the C++ side, we are running the sequence logic. So the way this is happening is it is processing the device statuses. So it's getting information via a JSON from the CODESYS application. So we're encoding all of that information from the different devices and interfaces with these devices into a JSON file. That JSON is being pulled up over OPC UA to the C++ application. It's processing all these device statuses and seeing any changes in the I/O. From there, it's going to run the sequence logic as we typically would in the PLC, but in this case on the C++ side. Then it's going to send these commands back to the devices. So then that packs that back into a JSON file. Those commands are sent over to CODESYS, and then CODESYS opens or processes the JSON file, sends the commands to the I/O. It checks for any interlocks, anything like that, so that we protect the machine. And then it updates the I/O statuses, packs that into JSON, and sends it back to the C++ application. From there, there's the EtherCAT connection to both the safety and all the I/O devices, such as, and then the safety PLC is living over there and processing all that entirely on its own, unrelated to any of this other stuff. So at the end of it, this ended up being really beneficial for the customer because, and has been running really well for them. So the client, as they wanted, was able to use existing software development processes for C++ and existing tools for all these different things, so that because they could have this in a Kubernetes cluster, they could utilize any of the existing tools and things that they're already used to without having to worry about figuring out how the industrial automation world works. This is also providing really a safe system for this because there's a very clear division of what part of the system is involved with which piece of the safety of it. So we know that the C++ is a sequence, PLC does machine protection, and the safety PLC does human protection. So it provided a couple different levels of protection so that for all the different systems and people involved, so that there was confidence in that side of it. The other thing is we're able to use this real-time control on the safety side the real-time control in the CODESYS side for that, so that they were able to use C++ in the first place. And then finally, they've also been able to do very rapid development via continuous integration testing and integration pipeline. So it's very simple, because once the hardware system was defined, we were able to finalize the PLC side of it itself, and they have the interfaces to go with it. And then anything that's in the sequence side can be developed quickly using their continuous integration and testing pipeline. And then that gives them full control on that side. The other thing is, because we have the different layers, particularly the safety PLC, that's not involved in the continuous testing and integration pipeline aspect of this. So we did a safety buy-off, locked that down, and then that's over. So that again provides the flexibility. Because of that separation, it gave the customer the flexibility to do quick integration and testing and rapid iteration without putting any type of the safety side or anything that could involve something going wrong into that risk cycle. A couple things. So this system is now up and running. It's been working pretty well now for a while. But in the future, there's a couple other things that we are looking at improving as things come out, things that we've heard about earlier today. So eventually the plan is to move the CODESYS application up into the server so that it runs at the same level as all of the other things. We haven't had any issue with this. This then removes some more of those layers for actually integrating everything. And at the same time also just helps keep everything in one place. There's also potential, we're still working with the client on this one, if that's going to happen, and as things are getting released and whether it makes sense, but potentially we're also going to move the safety application from this into a Docker container with the virtual safety PLC. So if we were to do both of these things, then we would end up removing the physical hardware entirely and running the entire control system on the server, and still able to utilize all these different tools such as advanced programming languages and tight integration from there, but still have access to the real time and the safety aspects that CODESYS provide for this.